We'll continue with question 7 of our prelim paper of 2022. So let's write down question 7. So let's look at our paper. In the circuit below, the battery has an EMF of 24 volts, right? We've got it as 24 volts and an internal resistance of 0.6 ohms. That's your internal resistance. The heater has a resistance of 10 ohms. The heater has a resistance of 10 ohms. And a fixed resistor has a resistance of 30 ohms. So that's another resistor in parallel where the heater has a resistance of 30 ohms. The variable resistor, a resistor that can change its resistance, has a can change between 0 and 15 ohms. So that's what we have here. 24 volt battery, excuse me, 0.6 ohms internal resistance, emitter in series, emitter in parallel to the 10 ohm resistor, 30 ohm 10 ohm heater, 30 ohm external resistor, and the variable resistor R is set at a resistance of 3.5 ohms. Okay, so this is all the information that is given. Calculate the total resistance of the circuit, including the battery. Okay, so you have to work out the internal the resistance of the circuit. How will we do that? We see here that we got the resistance of 0.6 that's internally in the battery. We got a resistor, a variable resistor of 3.5 ohms that is in series to the circuit, and we've got a parallel connection here. So to work out the total resistance of the circuit, we can work out the parallel resistance here, and we can add it to the 3.5 and we can add it to the 0.6 to calculate the total resistance of the circuit, which will include the battery. So let's go about it. So to begin with, resistors in parallel, 1 over Rp is equals to 1 over R1 plus 1 over R2. That will be equals to 1 over 10 and 1 over 30. 1 over 10 and 1 over 30. 1 over 10 plus 1 over 30. Right, and if you work this out, you get your LCM as 30 divided 3 plus 1, giving you 4 out of 30, but that's 1 over Rp. Don't forget, if you have to find Rp, it will be 4 over 30, so this will be 30 over 4, which will give you 7.5 ohms. So 7.5 ohms is the resistance of the parallel connection. So if you have to write this down, this is 7.5 ohms. So the total resistance of the battery, if we carry on, I'll write it on the side. RT will be equal to Rp plus the resistance of the rheostat plus the internal resistance. So in this case, your resistance in parallel is 7.5 plus the resistance of the resistor is 3.5 of the rheostat plus the resistance of the internal resistance is 0.6. So if you work this out, you'll say 7.5 plus 3.5 will be 7, 8, 9, 10, 11. 7.5 plus 3.5 plus 0.6, that will give you 7.5. 3.5 plus 11.6. This will give you the total resistance is 11.6 ohms. Don't forget the unit. So that will be 7.1's answer. So the resistance of the total resistance of the circuit gives you 11.6 ohms as the total resistance of the whole circuit, including the battery. The current measured by ammeter I2. So now if you have to work out the current going through I2, how are we going to do that? If you want to work out I, we have to have the V here and the R will be 10. So do we have the voltmeter? Do we have the voltage in parallel there? So we don't have the voltage in parallel. Let's see if we can calculate the voltage in parallel. 7.2. 7.2. So we need to work out the voltage in parallel, right? So we can say Vp is equals to I times Rp. So if you have to work out a voltage in parallel, we need the current in parallel. Do we have the current in parallel? No, we don't. We to work out even if you don't have the current in parallel, we have the total current in series and the voltage in parallel. So we're stuck. So we first need to work out the current that's going through the circuit. So to work out the current is equals to, if you look at the current, I is equals to V over R. What do we know? We just worked out the internal resistance of the battery. So let's go back. Let's just erase this again. Let's take everything out. What can we calculate so far? We can say the total, we want to work out total current, right? I total, I is equals to V over R. You can say I, the total I, equals to V total over R total. So do we have our I V total? We just worked it out in the sum before, it will be 11,6. The V total will be the voltage of the battery, but the total voltage of the circuit, which is 24. 24 volts is the total voltage of the battery. So we can say your total voltage is 24 and your total resistance is the one we worked out before. RT is equal to 11,6. So we can say RT is 11,6. And if you work that out here now, you can say 24 divided by 11,6, 24, 11,6, 2,07. That gives us 2,07 amperes. So that is the total current in the circuit, right? So if you have to work it out, we can say, what do we have to say? We've got a total current in the circuit, and what do we have to calculate? We have to calculate the current measured by ammeter A2. So we need to work out the current going through I2, right? So to work that out, let's just take out all our things that we have. The current in our circuit. So your voltage in parallel, if we have to work it out, can we work it out now? Voltage in parallel is equals to total current times your resistance in parallel. Do we have our total current in the circuit? Yes, it's 2,07. That's what we worked out. And the resistance in parallel, we worked out our resistance in parallel. We worked it out in a sum before. It came to 7,5 ohms. This is the parallel resistance. That means basically we're working out the current going through this whole parallel part here. So to do that, seven comma five. Do that and we work it out. 2,07 times 7,5, 15. We got 2,07 times 7,5, 15,53. If you round it off, right? 15,53 volts. So there's a voltage in parallel. Alright. So if we go here, we can say that the voltage here is 15,53 volts. So if you got our voltage here, sorry, the voltage on this resistor is 15,53 volts. So if it's 15,53 volts, we got our resistance R. Can we calculate I? I is equals to V over R. So let's just see if we can work it out. I for the what you call this? The 10 ohm resistor. Let's just put our subscripts. I for the 10 ohm resistor equals to V over R. And if you take that further, it's for the 10 ohm resistor, right? So the voltage is 15,53. We just worked it out in the sum before, and the resistance will be the 10 ohm resistor. So if we calculate that, 15,5 divided by 10, we get 1,55. We get 1,55 amperes. So that will be the answer that we are looking for. The current through the ammeter will be 1,55 amperes. It says 3 marks, and I'm looking at the answer. It should be more than 3 marks. 3 marks is too low for this question. 7.2, the question is the variable resistor is now adjusted to have an even higher resistance value. So now the resistance of the variable resistor increases. No more 3,5, it goes higher. How will this affect the power dissipated by the heater? Power, so what we should do is look at the equation that has power, and then from there we can come to a conclusion, right? How will this affect the power? Right, only increase, decrease, or remain the same. Explain your answer by making use of a simple equation. Whenever they ask a question, you should use an equation to come to an answer, right? So if the resistance of the resistor increases, yeah, the total current in the whole circuit will, because it's more resistance, the current will decrease, right? So we can say 7.2. 7.2. If the resistance of the resistor increases, of R, I call it R, right? The resistance of R increases, then we can say the total current will decrease. Now I said you must relate it to an equation, right? So we know that P is equals to I squared R. Correct. P is equals to I squared R. Thus, if I decreases, P will also decrease. If P decreases, I will also decrease. As P is directly proportional to I. Okay, so that will be an answer for 7.2. That should give you more or less 11 marks. Shukran. We will continue further.